Hello everyone, it's me again. Have you ever wondered how massive stellar behemoths can be, capable of swallowing our entire solar system whole? Yet, amidst that pitch-black freezing expanse, a single ray of sunlight cuts through the darkness, illuminating the tiny, fragile blue speck we call home. Gravity holds oceans to the crust, while ancient mountains slowly weather down into quiet dust. Beyond the whispering atmosphere lies the infinite silent vacuum of deep space. Jupiter dominates the planetary neighborhood as a swirling giant of banded ammonia storms and violent gales. Its immense mass dwarfs everything else in the solar system, yet it remains a failed cosmic experiment. Deep in the freezing shadow of the outer planets, brown dwarfs drift like ghostly, unlit embers. Their internal pressure struggles to ignite hydrogen fusion, managing only a faint, melancholic crimson glow. They linger in the twilight zone between massive planets and true living stars. True stellar ignition requires a monumental threshold of mass, crushing atoms together in a nuclear furnace. Red dwarfs cross that sacred threshold, small and dim, burning their sparse fuel with an agonizingly slow patience. Trillions of years will pass before these humble embers finally flicker out in the dark. Proxima Centauri hides just next door, a tiny red spark nearly invisible without powerful telescopes. Shift the perspective inward toward a golden powerhouse that rules our local realm with absolute authority. The sun pours blinding light across planetary orbits, driving solar winds and warming rocky surfaces. Nuclear fusion rages within its core, converting millions of tons of matter into pure radiant energy every second. Yet, on the grand cosmic stage, this yellow sovereign is merely an average player. Sirius flashes with a piercing white radiance, burning twice as massive and vastly hotter than our sun. Its brilliant light cuts across light-years of distance to dazzle the human night sky. Moving deeper into the galactic wilderness, blue-white giants pierce the dark with suicidal intensity. Beta Centauri houses colossal plasma engines that burn through their fuel in a geological blink of an eye. Entire generations of these blazing stars are born and erased before the sun can complete a single galactic orbit. Mass is a harsh dictator in stellar physics, demanding a catastrophic price for extreme brightness. R136A1 reigns supreme among heavyweights, packing 35 solar masses into a dangerously compact volume. It floods the surrounding void with intense ultraviolet radiation and blinding violet light. Stellar winds tear millions of tons of material away from its surface every single second. The monster lives on the absolute edge of structural collapse, defying normal rules of cosmic birth. Such titans are born only through the violent merger of multiple high-mass stars in dense nurseries. Their short lives flash like fireworks across the history of the universe. To find truly staggering, incomprehensible sizes, science must look toward the twilight of stellar evolution. When core hydrogen exhausts, the internal furnace contracts and heats up to violent new extremes. A desperate pushback against gravity forces the outer atmospheric layers to swell outward into monstrous proportions. Gigacrux inflates beyond its original boundaries, stretching a glowing orange shell across millions of kilometers. This dramatic swelling is a terrifying preview of our own sun's distant future. Billions of years from now, a bloated red giant sun will expand outward to consume the inner planets. The sky will turn a deep ominous crimson as the fiery shell swallows every trace of human history. Yet even standard red giants are microscopic when compared to the apex predators of the stellar ocean. Hypergiants emerge as the ultimate expression of stellar inflation, challenging human comprehension. Their surface gravity weakens to a fragile whisper, unable to anchor boiling layers of plasma. Powerful stellar winds rip through their expanding atmospheres, creating vast nebulae of gas and dust. The pistol star dazzles as a blue hypergiant, radiating an insane amount of energy into the void. Its brilliant blue light illuminates a turbulent region of space choked with interstellar debris. Yellow hypergiants follow, rarer than jewels and dangerously unstable in their magnificent scale. Rho Cassiopeiae shines with the brilliance of 500,000 suns, a golden beacon visible across the galaxy. If placed at the center of our solar system, its fiery surface would instantly engulf the orbit of Mars. Only a handful of these golden titans are known to exist, caught in a fleeting evolutionary transition. They flutter like giant moths between blue and red extremes before their inevitable destruction. Then comes the final tier of the giant contest, red hypergiants that blur the line between star and nebula. Measuring their exact boundaries is a nightmare for astronomers lost in heavy dust shrouds and erratic expansion. These solar system-sized behemoths are literally tearing themselves apart while shining with blinding luminosity. Among this elite group, one name stands out as the ultimate symbol of incomprehensible scale. Stephenson 218 dominates current measurements, stretching the laws of physics to the breaking point. Born from a massive progenitor, it has shed countless tons of material over millions of years. Its radius stretches outward by over 2,000 times that of our Sun. Drop this cosmic monster into the center of our solar system, and its outer edges would swallow Saturn whole. The orbits of Mercury, Venus, Earth, Mars, Jupiter, and the asteroid belt would all be buried deep inside. Light itself takes nearly 9 hours to complete a single journey around its bloated circumference. A commercial jet flying at top speed would require 5 centuries to circle its massive photosphere. By comparison, our Sun shrinks into a microscopic speck of dust floating in an infinite ocean. Human brains simply lack the neurological hardware to intuitively grasp such staggering physical dimensions. Yet even Stephenson 218 is bound by the relentless, unyielding laws of cosmic entropy. As heavy elements accumulate in its dense core, pressure mounts toward an inevitable cataclysm. The outer layers will eventually collapse and rebound in a core collapse supernova of unimaginable violence. That brilliant explosion will scatter processed metals, carbon, and oxygen back into the interstellar medium. From those scattered ashes, new generations of planets, moons, and life will eventually take shape. The death of a hypergiant is never truly an end, but rather a violent rebirth of chemical complexity. Space resets its cosmic clock, allowing gas clouds to condense and ignite fresh nuclear fires. Let us retrace this incredible journey, stripping away the numbers to witness the sheer poetry of scale. A solitary atom of hydrogen drifts through a cold molecular cloud, waiting for gravity to pull it close. Millions of companion atoms join the dance, forming a spinning disk of gathering mass and rising temperature. Friction builds inside the collapsing core, pushing the threshold closer to explosive ignition. A tiny red glow flickers to life in the darkness, humble yet unyielding against the freezing vacuum. Time accelerates as the red dwarf burns its microscopic fuel reserves across trillions of quiet years. Galaxies spin lazily in the background, weaving patterns of light across billions of light-years of distance. We shift our view toward a brighter yellow star, bathing rocky worlds in a steady, life-giving warmth. Sunspots ripple across its golden surface like magnetic scars, churning with suppressed thermal energy. Eruptions of plasma arch high into the corona, looping back down under intense magnetic guidance. Further out, binary stars pirouette around a shared center of mass in a timeless stellar waltz. Their light mixes into a brilliant amber hue, casting dual shadows across the surrounding vacuum. Then the scale expands exponentially, leaving ordinary stars far behind in the dust of our imagination. Blue hypergiants flare like welding torches in the night, illuminating distant dust lanes with harsh ultraviolet rays. Wisps of gas are stripped away from their equators, forming delicate veils of glowing neon plasma. The environment grows increasingly chaotic as the boundaries between star and space begin to dissolve. Dense stellar winds collide with older ejected material, creating shockwaves that ripple through the nebula. We approach the domain of the yellow hypergiants, where fragile atmospheres shimmer like golden silk. Convective cells the size of continents bubble up from the interior, carrying searing heat to the surface. Radiation pressure pushes outward with relentless force, keeping the massive envelope suspended by a thread. One can almost feel the phantom heat radiating across the digital void, a simulation of absolute majesty. The camera glides past towering walls of dust, revealing the reddish glow of an approaching titan. Stephenson 218 fills the entire field of view, blotting out background constellations with its sheer bulk. Its surface is not a clean solid line, but a roiling ocean of incandescent gas and flickering prominences. Huge plumes of vaporized material drift away from the limb, captured by the weak surface gravity. A lone photon begins its long journey around the stellar circumference, embarking on an 8-hour marathon. It skims across mountainous waves of plasma, dodging magnetic flares and intense thermal currents. The sheer emptiness of the space around the star emphasizes its lonely, towering dominance. No planets can orbit safely this far out. Any companion would have been consumed long ago. The star exists in splendid isolation, a monument to the extreme limits of stellar mass assembly. Behind it, the spiral arms of the Milky Way rotate like a giant pinwheel of silver and gold. Distant galaxies shine as faint smudges of light, reminding us that our galaxy is just one of billions. The camera pulls back further, reducing the hypergiant to a bright pixel, then a tiny spark, then nothing at all. We find ourselves floating once again in the familiar quiet of our own local planetary system. A pale blue dot hangs suspended in a sunbeam, breathtakingly small against the deep backdrop. Every human emotion, every triumph, and every tragedy occurred within that microscopic pocket of space. The vastness of the universe does not diminish our existence, but rather magnifies the miracle of consciousness. To be able to measure these cosmic giants is a profound triumph of human curiosity and intellect. We look up at the night sky, not with fear, but with a deep, humbling sense of connection. Every heavier element in our bodies, iron, calcium, carbon, was forged in the heart of an ancient dying star. We are quite literally made of stardust, walking pieces of the universe contemplating its own architecture. The journey from a grain of dust to a hypergiant spans scales that defy common sense. Yet every step is governed by the same elegant laws of physics, operating across different magnitudes. Gravity pulls together what pressure forces apart, creating a delicate dance of eternal balance. Even as stars die, their remains seed the cosmos with the ingredients for new worlds to form. The cycle is unbroken, stretching from the dawn of time into the infinite future. Future astronomers will undoubtedly discover even larger anomalies hidden in remote corners of space. Instruments will grow sharper, revealing details currently obscured by thick interstellar dust clouds. The title of the largest star will shift and evolve as our technological prowess deepens. Yet the sense of wonder will remain untouched, a permanent fixture of the human condition. Technology allows us to bridge the gaps, translating raw data into breathtaking visual poetry. Applications like Universe in a Nutshell let us slide seamlessly from subatomic scales to galactic webs. The ability to zoom through dimensions empowers our minds to grasp what the eyes cannot see. We trace the lineage of matter from the smallest subatomic particles to the largest stellar hypergiants. Each layer reveals new complexities, proving that simplicity is often just a lack of resolution. A drop of water contains more molecules than there are stars in our observable neighborhood. A hypergiant contains enough material to birth millions of planetary systems simultaneously. Extremes meet in the middle of our understanding, bound by mathematical elegance and cosmic harmony. We pause to reflect on the quiet majesty of the empty spaces between celestial bodies. Starlight travels for centuries across those voids before finally striking the lens of a telescope. When we view a distant star, we are literally looking backward into the ancient history of the universe. The light of Stephenson 218 left its surface long before modern human civilization began to dawn. That temporal distance adds a layer of profound melancholy to our astronomical observations. Many of these hypergiants may have already collapsed into black holes while their light is still traveling. We are witnessing ghosts of the cosmos, glowing relics echoing across the dark. The fleeting nature of massive stars teaches us about the urgency and beauty of impermanence. Nothing in the universe remains static, and change is the only constant rule of survival. From burning gas giants to towering red hypergiants, every phase plays a vital role in galactic evolution. The symphony of creation and destruction plays out on a canvas without boundaries. We stand at the edge of this grand theater, clutching our scientific instruments like lanterns in the dark. The answers we uncover only lead to deeper, more fascinating questions about our place in the cosmos. Let the scale of the universe humble your worries and elevate your imagination to new heights. Whenever you look up at the night sky, remember the invisible titans hiding behind the veil of distance. Remember that the sun itself is just one ordinary ember in a boundless sea of burning lights. Remember that you carry the ashes of exploded giants within the very structure of your physical form. The largest star in the universe is a temporary king, destined to fall so that new life may rise. We are all participants in this magnificent, unending cycle of cosmic transformation. Keep looking upward, keep questioning, and keep exploring the infinite wonders of the dark. The story of the stars is ultimately the story of our own origins written across the night. Until our next journey into the unknown, let the quiet majesty of the cosmos guide your thoughts. Space bends and twists under the immense weight of these stellar behemoths, creating gravitational mirages. Every flicker of light carries secrets from the deep past across unfathomable gulfs of distance. We stand humbled at the cosmic shore, gazing out at an endless ocean of burning giants. The journey never truly ends. It merely pauses until the next star awakens in the dark.